let's say task 3. So in each of these additional tasks, they present to you a very slight variation of this concrete pipe pendulum. For instance, the task 3 script talks about a pendulum where the pivot point is mounted on a bracket that potentially can slide backwards and forwards. So if you'd like to explore what happens when we incorporate that sort of dynamics into our model, well, let's just run this script. I'm just going to move up to the green run triangle. I'm just going to run the script in its entirety. It's going to open up a Simulink file that only has a Simscape model in it. And we can sort of run this, and we can kind of see the resulting simulation. So I'll leave it to you to read in more detail the commentary that is inside the task 3 script, and you can sort of explore that on your own. All right, so that's just a time check. So apparently we have 20 minutes left. So this has just covered this case study, which is the pipe pendulum. Let's go back to the root folder, and I'm just on the way. I'm just going to clear my workspace. So we've just finished looking at this guy. So the next case study in the remaining 20 minutes is we're going to look at this virtual lab called Pendulum Impacting a Block. So I really need to make sure that you're comfortable being able to open the files and run the files for this virtual lab. So let's navigate into this Pendulum Impacting Block folder. Alrighty. So if you're following along at home, I'm hoping that your present working directory is this one. And when you get yourself into that present working directory, you should see these files. And on this occasion, there is one of those start here, please files. So let's just double click on this start here, please file. Let's see what it's got to tell us. Alrighty. So in this virtual lab, this is the mechanical apparatus that we're going to sort of explore. It consists of a pendulum, which is allowed to swing, and the pendulum collides with a block that is resting on the table. And due to that impact event, the pendulum ricochets and the block is sent flying across the table. So this is the apparatus that we're going to play with. And you'll see that just like we did before, we can parameterize this apparatus. Let me just point out a couple of those things. We have the length of the pendulum, we have the mass of the pendulum, and we also have the block. So we're able to sort of specify that the mass of the block that's on the table. As I sort of scroll down this start here script, apparently there are 3 tasks that we're going to do. So let's have a look at each of those in turn. So I'll get you to click on task 1 first. Let's see what that's about. So task 1 is nothing more than getting you familiar with the MATLAB variables that we've used to parameterize this apparatus. So as I just sort of scroll down the screen, I get to the instructions. Well, apparently instructions are, look, just run the script, man. So I click on the Live Editor tab sheet. I then look for that big green run triangle, and I just click on it. And as I sort of scroll down the script, you'll sort of see that embedded within this script, we've got the capacity to sort of specify values for some of these important parameters that characterize our mechanical apparatus. For example, you'll see that there's a slider bar for specifying the mass of the pendulum, the length of the pendulum arm. There's a slider bar that allows us to specify the mass of the block that's on the table. Let me sort of scroll down to the bottom of this task 1 script. That's going to get us to next steps. So at the very bottom of the script, you'll see there's a next step, and there's a little icon, a link, pardon me. There's a link called task 2. So let's just click on task 2. Let's see what that does for us. So the task 2 script opens up. Let's scroll down the screen. It's reminding you of what your prerequisites were. So let me just double check on my system. Does my workspace look like that? And yes, it does. That's because I ran task 1. Thank you. Then the instructions say, do not run this script by clicking the run button. Okay. Apparently there's a little video that you can watch. But as I scroll down to step number 2, it's gonna say, hey, why don't you just click this button? It's gonna open a Simulink file. So let's do that. Let's click on that button. So when you click on that button, here's the model. Here's the model that sort of opens up. If it looks too small, if it looks too big, just click anywhere on the white canvas and hit the spacebar. So, all right, the model opened, but I kind of feel that there was a little bit more instruction that we had to read. So yeah, apparently in this task 2 script, there are 2 experiments that we need to do. So the first experiment, it involves sort of specifying that the pendulum mass should be 5 kilograms, the pendulum arm should be 0.5 meters, and the block that's on the table should be 3 kilograms. So in order to make those changes, we need to go back to our task 1 script. We need to interact with those slider bars. So that's what I'm going to do. I'm just going to click on that little link. So we're back now to the task 1 script, and I'm going to scroll up to the top. And according to the instructions, we need to dial in 5 kilograms for the pendulum mass. The length of the pendulum was 0.5, so I don't even need to change that. And I need to make sure that the block was also dialed in at 3, which just happens to be where it was anyway. So you need to make these changes. 1, make sure that's 0.5, and make sure that's 3. So once you've made those changes, let's go back to the Simulink file, and let's just click the run button. Let's run our simulation. So when you run your sim, we've got results that are not entirely unexpected. All right. So we have this really heavy pendulum mass. It's got quite a lot of kinetic energy, and it collides with the green block that's on the table, and the block gets shot across the table. All right. So what else does our script in task 2 tell us? What else are we supposed to note? We're supposed to note that inside the model, there's a subsystem called data logger. And inside the data logger subsystem of our model, there's one of those little oscilloscope blocks that we can sort of look at. So let's go and find that data logger subsystem in our Simulink file, and let's then open the scope. So here's my Simulink file, and here's the data logger subsystem tab sheet. I'm just going to click on that. And I'm going to hit the space bar. And here's the oscilloscope that we were supposed to double click on. So once you've found that oscilloscope, just double tap on it. That should open it up. So when you open your oscilloscope, the time series traces have been color coded. Green is obviously the data for the green block, and red is the data for the pendulum bob. So let's get you really comfortable with what these time series plots are. So this first one, as its title suggests, this is a time series plot that shows the position of the green block. You can kind of see that for quite a few seconds in the simulation, it was at position 0, horizontally, and then it continued to sort of move until it came to a stop, right? The other green axis is the velocity of the horizontal velocity of the green block. You can clearly see the impact collision event causes almost a discontinuity almost in the velocity. It went from being from a standstill to almost instantaneously having an initial velocity. And if you stare at that velocity time series profile long enough, you'll see that the velocity seems to decrease in a really nice linear fashion until ultimately the velocity comes down to 0, which means the block is stationary once again. So we've got our 2 green traces, which are for the green block. If we now look at the 3 red plots that are on the right-hand side, well, these red plots are showing plots of the pendulum bob. Let's just have a look at them. So this top one sort of shows the vertical position of the pendulum bob. According to some reference datum, the pendulum was initially approximately 0.5 meters above the datum. It then swung down, and you can sort of see the series of swaying, oscillating sort of events that the pendulum experienced. The next trace is the horizontal, the x-axis velocity of the pendulum. So this is that. And the last one is just sort of showing what the magnitude of the pendulum's velocity is versus time. All right, so you know where to find the scope block, and you know what the meaning of these time traces are. Let's go back to the script. So I think there was one more experiment that we needed to do. And that experiment was, well, let's go back and let's significantly reduce the mass of the pendulum. Let's dial it down to only 1 kilogram. We'll keep the other 2 parameters at the same values. So let's go back to our task 1 script. Just click on this link. And let's grab that slider bar and let's move it over to 1. So for our second experiment, the 3 parameters that we want to make sure have been dialed in correctly is 1 for the pendulum mass, 0.5 for the arm of the pendulum meters, and 3 kilograms again for the block that's resting on the table. Once you've dialed these 3 parameters, let's go to our Simulink file and let's hit the run button again. We kind of bring our animation viewer back to screen. Let me just go to the playback and let's watch the replay. And you know, with less sort of kinetic energy within the pendulum bob at moment of impact, clearly the green block, you know, we're expecting it not to slide as far as it did in experiment 1, and we're sort of seeing that visually in this animation viewer. If we go to that scope block again and just bring up what it looks like this time and have a look at it. Clearly the final resting position of the green block, it didn't slide as far. It only moved around about 0.28 meters in this second experiment. All right, so that's experiment 2 done. We can go back to the script and let's see what it wants us to do now. So after you've done experiment 2, we're actually going to analyze the time series data that we've measured from experiment 2. So let's click on that task 3 hyperlink. So here's the task 3 hyperlink. And folks, we only have 5 more minutes together, unfortunately. So what I'm going to ask you to do is I'm going to ask you to simply run this task 3 script. Just run it, okay? This will run the script in its entirety. You will need to review this task 3 script in more detail on your own. But after running it, let me just sort of scroll through it and I'll just call out what it's done for us. So what it's done is it's brought in the simulation data from experiment 3. So hopefully as I scroll down the script, you'll see very, very similar sort of plots to begin with. So this time series plot looks very familiar to you, doesn't it? It's the position, the horizontal position of the green block. It's also the horizontal velocity of the green block. We saw this within the Simulink model. We'll keep scrolling down. When we actually interrogate the data that is in that time series plot, we can answer the question, how far did the green block actually slide? And we can also answer the question, for how many seconds was the green block actually in motion for until it came to a stop? So we can kind of answer those 2 really basic questions just by interrogating these 2 time series plots. We can do a similar sort of plot of some of the red pendulum bob data, again, plots that we sort of saw in the Simulink file. And when we sort of do that, we can also pull out some really fundamental sort of attributes out of those plots. We can answer the question, what was the starting height of the pendulum? We can answer, after the collision event, the pendulum bounced back and then it came to a halt. When it came to a halt, what was the height of the pendulum bob? So we can sort of answer these basic questions. What we're going to do now is we're going to use these measured quantities to compute the coefficient of kinetic friction. Yeah. So as I said, in the interest of time, I can't go through each of these steps in detail with you, but I'm hoping that you're comfortable enough to sort of review the commentary that is in these scripts. But you'll see what it does is it sort of takes a snapshot at 3 or 4 moments in time. For example, at time t equals 0, when I just released the pendulum, what can we sort of deduce about the kinetic energy of the pendulum bob? At time t1, the moment of impact, what can we sort of talk about the transfer of energy from kinetic to potential for the pendulum bob? So I'll let you sort of review this, all right? And the ultimate sort of conclusion is that by just focusing on positions and durations of quantities that we can measure from our experiment, lo and behold, we actually get ourselves to the point where we can use Newton's second law applied to the sliding brick. We can confirm that there is a constant deceleration acting on that green brick. And that's why the velocity profile, if you recall, was a nice linear decreasing velocity profile. And in conjunction with some of the measured and derived quantities, we can now get ourselves in a position where we can actually compute the kinetic coefficient of sliding friction. And the value of that coefficient of friction is 0.304. So taking some measurements, taking some fundamental energy principles, the principle of work energy, the principle of impulse and momentum, and combining all of those things, we've now got ourselves to this. We believe that for this apparatus that we've just interacted with, the kinetic coefficient of sliding friction is 0.304. And that's a really, really good thing, folks, because if I go back to my task 1 script, it actually turns out that the model that we interacted with really was configured to implement a 0.3 kinetic coefficient of friction. So it's really reassuring to know that we can go from measurements, implementing a couple of engineering principles, and they all converge to what we expect, which is a really nice feel-good moment. Okay, we have unfortunately run out of time. I'm hoping that was a nice walkthrough of the files associated with this particular virtual lab, and that you're also now confident enough to be able to go back, open them, and redo what we've just done together over the last sort of 20 minutes. So folks, again, apologies. I do not know why our Zoom session did not start at 11 a.m., but that's something to be resolved later. Thank you very much for your time this morning.